All right, welcome back. So now let's take a closer look at radian and degrees, how they relate together. This video is a little bit longer video, one of the longer videos. We're going to cover a lot of stuff. Remember, you can rewatch these videos on the YouTube channel, and you can stop them and rewind them and spend some more time with them looking at the examples. So the first thing I want to do is convert between degrees and radians. So let's look at some examples where we convert from degrees to radians. So for the first one, I'd like to do 45 degrees. And let's do this one together. I'll go ahead and do this one. So 45 degrees, we're going to multiply by that conversion factor that we looked at, 45 degrees. Now the conversion factor is I want to have the 180 degrees in the denominator so that degrees will cancel, and I'm going to have pi radians in the top. This is the unit conversion. Pi radian is the same thing as 180 degrees. This is 1. But as I multiply them together, the degrees cancel each other out, and I'm left with pi radians. Now as we divide this, 45 divided by 180, 45 divided by 180, it gives me 0.25. I'm going to convert that to a fraction. Hit the math button, convert to fraction, 1/4 pi. The way we're going to write this, 1/4 pi, we're going to write pi over 4 radians. Later, we won't even write the radians anymore when we're using radian measures all the time. All right, here's one for you to try. Try 300 degrees. I'll pause for a minute. You don't have to stop the video. Go ahead and convert that to radians. So 300 degrees times pi radians over 180. The degrees cancel. 300 divided by 180, I'm going to get some sort of fraction here. 300 divided by 180, but give me the answer as a fraction, 5/3. So this is going to be 5 pi over 3 radians, 5/3 of pi. And we're going to write it like this, 5 pi over 3. All right, here's another one to try. How about 240 degrees? Again, I'll pause for a moment, give you a chance to try this one. (240 degrees times pi radians over 180 degrees. The degrees cancel. I'm going to get some radians. 240 divided by 180. 240 divided by 180. Give me the answer as a fraction. 4/3. In other words, 4 pi over 3 radians. All right, now let's convert the other way. Let's convert from radians to degrees. Convert a radian measure to degrees. All right, so let's take a look at pi over 6 radians. How do I convert this to degrees? Well, I'm going to multiply it by my unit ratio again. So pi over 6 radians. This time I want radians in the bottom. So pi radians goes here, and 180 degrees goes there. Again, this is the unit conversion. The radians cancel, the pi's cancel, and I'm going to get 180 divided by 6, 30 degrees. All right, let me give you one to try. Convert 3 pi over 2 radians. Convert that to degrees. So again, I'm going to take the 3 pi over 2 radians times 180 degrees divided by pi radians. The radians and pi's cancel. 3 times 180 divided by 2. 180 divided by 2 is 90 times 3. 270 degrees. All right, one more. How about 5 pi over 3? Convert to degrees. Five pi over 3 radians times 180 degrees over pi radians. Radians cancel the pi's. 5 times 180 divided by 3. 5 times 180 divided by 3. And it is 300 degrees. If some of these angles sound or look familiar, I'm focusing in on the reference angles that we should know. Now, I want to do something a little different for this next part, so I'm going to ask you to do something for me. I want you to, let's see, we can put our calculators away. We don't need that. So I want you to take your notebooks, and I want you to turn them sideways. So when you turn them sideways, your little spirals are up here. Find a nice new blank page. The spirals will be up here. The holes for the clips will be somewhere over here. So the whole notebook's going to be sideways now. And what we're going to do is we're going to create a chart looking at the common angles, both degrees and radians, that we really should know. We should know all of these. All right, so we're going to use the whole piece of paper here. Nice new blank piece of paper. And I'm going to draw a line here all the way to the end and a line over here. And these are going to represent 0 degrees and 360 degrees. All of my angles in degrees will be up here. The corresponding angle in radians will be down here. 0 degrees is 0 pi radians. 360 degrees, a whole circle, is 2 pi radians. Halfway in the middle, 180 degrees is pi radians. A half of a half, here and here. This will give me 90 degrees plus 90 plus another 90, 270 degrees. Half of pi is pi over 2 pi, and then add another pi over 2 to that. I get 3 pi over 2. And now I want to put some more angles in here. But before I do, I want you to notice that each of these is actually a quadrant on the circle. Between 0 and 90 degrees, these are all the angles in the first quadrant. Between 90 and 180, these are all the angles in the second quadrant. Between 180 and 270, this represents the angles in the third quadrant. And 270 to 360 degrees, this represents all the angles in the fourth quadrant. So I want to take a look at the halfway points here. Halfway between 0 and 90 is 45 degrees. Halfway between 0 and pi over 2 is going to be pi over 4. 45 degrees is pi over 4. In the second quadrant, halfway here would be 135 degrees. And halfway between pi over 2 and pi would be 3 pi over 4. Next, halfway in the third quadrant, halfway from 180 to 270 would be 225 degrees. And this would be, the corresponding radian would be 5 pi over 4. And then in the fourth quadrant, the angle would be 315 degrees. The corresponding angle in radians would be 7 pi over 4. Now we've just broken it up into pi over 4s. 0 pi over 4, 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is just pi, 5 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is 2 pi. Correspondingly, 0 degrees, 45, plus 45 is 90, plus 45 is 135, plus 45 is 180, and so on. I want to look at some more angles. These angles would be here, a 30-degree angle, which would correspond to pi over 6, and the 60-degree angle, which would correspond to pi over 3. And notice we're not doing 15 or 75 degrees, just these angles. And I want to look at what would these angles be in the other quadrants. So here, on either side of 135, I'm going to have 120 degrees and 150 degrees. The corresponding radian measures would be 2 pi over 3 and 5 pi over 6. In the third quadrant, I'm going to have 210 degrees and 240 degrees. The corresponding radian angles would be 7 pi over 6 and 4 pi over 3. And then finally in the fourth quadrant, my angles in degrees would be 300 degrees and 330 degrees. Corresponding radian measures would be 5 pi over 3 and 11 pi over 6. So we've broken this up into pi's over 6's now. If I add it through, 0 pi, pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6, which would be pi, 7 pi over 6, 8 pi over 6 reduces to 4 pi over 3, 9 pi over 6, 3 pi over 2, 10 pi over 6, which is 5 pi over 3, 11 pi over 6, and then 12 pi over 6. These are all the measures that we need to know, and their corresponding radians. And we really need to know these. We need to know these cold. Now, don't run home and try to memorize all of these. Hopefully, we'll be using them a lot. You'll get used to them, and you'll be able to make all of these connections. When I return, we'll actually play a game. We'll play a flashcard game where I'll throw a degree at you, one of these degrees, and you have to give me the radian measures. Or I throw you the radian, and you have to tell me the corresponding degrees. But these are the ones that we really should know. We should know these very quickly to be able to convert with these. All right, so let's take a look at an example now. What can we do with all of this and the idea of a radian measure? I want to take a look at a racetrack. Now, in this particular racetrack, there's the straightaway, and then there's a curve. So in the first lane, and then it curves. And in the second lane, and it also curves. So if I take a look at these two lanes, and I'm going to call them lane 1, lane 2. Now if you're running in the lanes, lane 1 is actually going to be shorter around the curve. On the straightaways they're the same, but lane 2 is actually going to be a little bit longer. You're going to have to run a little bit longer. So the question is, how much longer would you have to run? Well, if we take a look at the radiuses, so if I take a look at the radius from the center of this arc to here, and let's say this radius is 33 meters. And then each of the lanes are 1 meter in length, 1 meter in length. So if I want to find the length of the curve, find the length of the curve. And let's take a look at each one of them. We're going to do lane 1 and lane 2. Now I know the length of the curve, that's just arc length. And we have a special formula for that. Arc length, S, is equal to the radius times theta, as long as that's in radians. So the arc length is the radius times the angle in radians. Here's the angle. what would that angle be in radians? 180 degrees, it would be pi. So let's take a look at each of the lanes. First, lane 1. Lane 1, the arc length would be the radius, 33 meters, times the angle in radians, which is pi. Lane 2, the arc length, the length of the arc, is the radius. Now I have an extra meter here, so it's going to be 34 times the angle pi. Now as you look at this, you might say, well, really, is that it? Is that all there is to it? Yes, the difference is just going to be pi. So one is going to be pi longer, which we know is approximately 3.14 meters. So if the race had to go around the track 4 times, you're going to be going through this arc 4 times. Then 4 pi meters. Each lane is going to be 4 pi meters longer. That's why we have the staggered starts. 4 pi meters for a race that goes around 4 times. Let's look at another application. And I want to consider a mile. 1 mile. We know that 1 mile is about 5,280 feet. And this is the linear or the statute mile. 1 linear mile. 1 nice straight mile. But the Earth is a curved surface. Sorry, flat earthers. And the definition of a mile is actually the length of the arc. So this length right here is going to represent 1 nautical mile, and it's curved. The statute mile, think about it as flat, and it's defined as the arc of a 1 minute angle. Remember, there's 60 minutes in every degree. So if I want to find the arc length using the formula, we know, again, the formula is the arc length is the radius times the angle, as long as the angle is in radians. So this arc length, how long is this in regular miles? Well, if I think about the Earth and the radius of the Earth, I can tell you that the diameter of the Earth is approximately 7,912.18 miles. So I'm going to need the radius, half of that, and the angle, but in radians. I'm going to have to convert that to radians. All right, so let's convert 1 minute to radians. 1 minute angle to radians. Well, 1 minute is 1/60th of a degree times my pi over 180 degrees. And if I multiply this out, I'm going to use my calculator here. I'm going to get a decimal. 1 divided by 60 times pi divided by 180. I'm getting scientific notation number here. So this is approximately, let's see, times 10 to the 4th, so 3 zeros. 1, 2, 3, and then 2, 9, 0, and then a bunch of 8s. Approximately that in radians. Remember, this is an angle now. This is an angle. We just converted from degrees to radians. This is a radian angle. So now I can find the arc length. My arc length, so 1 nautical mile is going to be the radius, so it's going to be 7,912.18 divided by 2, that's the radius, times the arc length, this number right here, my 0.000290888 approximately, which is approximately, so let's see, I'm going to take that and I'm going to multiply that times 7,912.18 miles divided by 2, because that's the diameter, and I get approximately 1.15. So what does this mean? This means that a nautical mile is approximately the same thing as, 1 nautical mile is approximately the same thing as 1.15 statute miles, linear miles, flat miles. So the nautical mile is a lot longer because it's curved. If I drew a chord here, a chord connecting these 2 points, that would be 1 mile long. But the curve is a little bit longer. So a nautical mile is just a little bit longer than a statute mile. All right, let's take a look at another example. Here's an interesting example. Suppose a company that manufactures tires got a company that manufactures tires, and they've got a new type of truck tire. It's a specialty tire with 36-inch diameter. So I've got a 36-inch diameter tire. But after testing, they've discovered that this thing is only safe up to 630 revolutions per minute. So when they tested this in the lab, spinning the tire was good up to 630 revolutions per minute. But if it got faster than that, maybe the tire fell apart, or there was some problems, or it destabilized, or I don't know, whatever. So they want to put a warning. They want to make sure that when you put this on the trucks, that you don't travel faster than 630 revolutions per minute. But if they put that warning on there, that really doesn't make sense to anybody. What would make sense? Well, we really want to be able to tell people miles per hour. What's the limit in miles per hour? So I have to convert. Now, this is something called the 630 revolutions per minute. This is an angular speed. And I want to convert to a linear speed, like miles, linear, flat, miles per hour. So angular, spinning, rotations, 630 rotations per minute. I want to convert that to a linear speed. So it's all about the unit conversions now, just like converting from degrees to radians and radians to degrees. So here we go. Let's set this up and see what is the corresponding miles per hour. So I've got 630 revolutions per minute. I'm going to multiply by a whole bunch of unit conversions to change it. First thing I want to do is I'm going to change minutes to hours. So my first rate I'm going to multiply by is, I know that there are 60 minutes in 1 hour. So what's going to happen after this conversion? I'm going to have revolutions per hour. Well, I've got the right time unit, hours, but I need to convert revolutions to miles. So as I take a look at this, what's going to be my first conversion? Well, 1 revolution, if we take a closer look at this truck tire, and we know that the diameter is 36 inches, 1 revolution, if I start here and go all the way around 1 time, that's really the circumference of the tire. Circumference equals 2 times pi times r, or pi times diameter. So the circumference of this wheel is 36 pi inches. Pi times diameter. So I've got the circumference. Now, I can use the following conversion. 1 revolution is 36 pi inches. So now I've converted from my angular speed revolutions, and now I know inches per hour. I still need to convert that. I need to change this. So for inches, I need to change to feet and then to miles. I know that 12 inches is 1 foot. And I also know that 5,280 feet is 1 mile. and the inches are going to cancel, and the feet are going to cancel, and I'm going to have miles per hour. So I need to multiply all these numbers here in the top and all of these in the bottom, and my final answer will be in miles per hour. All right, here we go. So I'm gonna open parentheses, and I'm going to do 630 times 60 times 36 times my pi key times 1 times 1. That's my numerator. Divided by the denominator, open parentheses, I've got 1 times 1 times 12 times 5,280, close parentheses. That's my denominator. And I get the following answer, 67.47. Now, what does this mean? Well, we converted 630 revolutions per minute to miles per hour. 67.47 miles per hour. That is the safety of this tire. Don't drive this tire faster than 67.47 miles per hour. So the company might put a warning on the tire. Maybe they'd round it down to 65 miles an hour. Warning, do not drive faster than 65 miles per hour on these tires. All right, so this is our first lesson in trig. We've still got a long way to go, lots of other concepts to look at here. But take a look at these ideas, the degrees and radians, converting back and forth, and some of the basic things we can do with degrees and radians, and the idea of all the circles. And also the angles, the angles that we really need to know, and the conversion between the reference angles in degrees and radians and back and forth. And as we use these more and more, you're going to memorize them probably whether you want to or not. All right, so we can get working on the homework if there's any time left, and good luck.